be starting with exam prep. So there has been on the WhatsApp group a preliminary exam date shared. So it seems like prelim exam date is around, let me quickly check, for 26th of October. So we will probably get a bit more clarity on that in the next week or so, but at the moment, 26 October. So it gives us basically a month and about 2 weeks, 3 weeks to get everything sorted out, that you guys are prepared for the exam. So the more sessions, the better. So I think also if anyone from 1510, if when you guys know your date, share that as well. When you can also share questions with me that we need to look at. Tonight, we are also going to look at questions that was shared, and then also other questions that I have. So we just, and you can see at the moment there's about 39 slides. So I am adding more slides. So we will just, as I get more questions, we can throw it into the pack. We will work through it. In the end, we probably would have looked at 100 to 150 different exam questions. So, and I think that is a good prep for you guys, because we have seen a lot of times a lot of the same types of questions all being asked over and over again. So that is the aim, just to make sure you get enough prep in. Okay, so let's look at this first question. It was one of the nearly assignment 4 prep questions. So let's look at it, and let's look at what you need to do. So a random sample of size n 100 in a sample mean of 100 as well. Okay, so sample mean of 100, the population standard deviation is 35. What is the value of the standard error of the mean? Okay, so remember, if we look at this Z formula, when we work out the Z value, the component below the line, the standard deviation divided by the square root of n, that is your standard error. Okay, so what they want us to work out is the standard error. So let me just quickly get this back to the normal size. Okay, so they want us just to work out what is the standard error. So it's standard deviation 35 divided by square root of 100. Square root of 100 is 10. So 35 divided by 10 will give you 3.5. Okay, so that is how we will get to this answer. So we don't need to work out Z. You in any case don't have the population mean. You only have a sample mean, so or the X you don't, so you can't really work out Z value. So the only thing that you can work out with that is nearly the standard error, else you would need more information. But basically, standard error is the population standard deviation divided by the square root of the sample. Okay, so that's the first one that we look at. So let's look at another question. Was also from study unit 4, and then what I'm also then bringing in, so we'll change this up a bit. So then we will go into another question as well. So household survey based on a sample of 50 households in a small rural village found the average household income to be 3,000. So we look at it, it is confidence interval. So nearly the first thing I will normally do is to say, okay, we're working with confidence interval. It might be that we need to work with a Z, or we might need to work with a T. So Z is when population standard deviation is known. T is when it is unknown. So let's look at again at what they tell us. A household survey based on a sample 50 household found the average income to be 300 or 3,000 with a standard deviation. Okay, so they tell us the sample standard deviation. So we don't know what the population standard deviation is. So we need to work with the T. Okay, so we don't know population standard deviation. So we work with a T. So this would, the standard error component stays very similar, but instead of now using the 95 where we could have said 95 is always 1,96 when we look at the Z, now we need to look at what is the T value. So let's just again, so we've got the 3,000 plus minus, we've got the standard deviation of a sample, it's 900. We've got the N, which is 50. Okay, so that part of the equation is done. So now just for T, we need degrees of freedom, and we need alpha divided by 2. And remember now, we're fresh from chi-square, nearly chapter 10. When we looked at that, it was only alpha, it was never alpha divided by 2. So just remember, when we work with a T, it is alpha divided by 2. And the degrees of freedom is, in this case, n minus 1. So just again, a bit different. That's why I also nearly wanted to show this again, so that in the exam, there's no nearly a break from a one to the other one. So you guys will need to remember which one to use where. So degrees of freedom, n minus 1. So we have the n as 50. So T 49. And we know that for alpha is 0,05. So 0,05. 0.05 divided by 2. Okay, which will be 0.025 when we get to it, but so we need to get to the t table. So let me just open it, that we can go into it. Okay, so let's see where the t table is again. So that was standard. Okay, here we go. Okay, so let's just, so we were at T49. Ah, okay. So there was the T49 0.025, the 2.0096. 2.0096. Okay, so let's get the calculator to work out that. Again, some of your calculators are cleverer than my HP, so I now first need to work out the standard error because it does not allow me to do too many functions at the same time. So 900 divided by the square root of 50 gives me 127.279. I multiply that by 2.0096. I get that I will plus minus the 3000 by 255.78. So again, depending on how much you're rounding off, your top one will be 3255. If I look at options, there's 3255. Not okay. So that would then be my answer. I think if you set 900 divided by square root of 50, which is 7.0071, and you multiply that by 2. No, I made a mistake. So 900 divided by the square root of 50. So if I used 127.28, it was rounded off. So I just want to check if we get to, yeah. So you will see, depending on with what you round it off, you get closer to that number. But by a few decimals, I'm not too worried about that. So you will also see in your exam that you will not get a number of 5255.78 and 255.83. So you will get the one that is the closest. Okay, but the most important part here is to see which one, if it is a population standard deviation that is known or unknown, so that you know if you need to use the Z or the T. Also, and the lecturer said how they are going to mark is, so if this will count 4 marks probably. So if you set A and you got it, you will get your 4 out of 4. If you went with the answer that was in this instance a T, but you still did the rest correctly, and it might now be that that option is then C or E C or D maybe, then what will happen, that is when you will get a mark or 2 marks. So the exam will be as in your assignment. So it's not a 0 or 4. You might even get a mark or 2 marks if you still did the right process, but in the end got the wrong answer. So just remember that they will mark if you have done something that is still correct in the process. Okay, so as I said, I'm going to jump between questions, just so that we also get a bit of previous. Okay, why? I just quickly want to. This is weird. I want. Okay, cool. So this is from, sure, I think an assignment of 2 or 3 years ago. So still the same process as you guys have been doing this year as well. For your assignments, every question was nearly 2 marks, but also if you get it close to the answer, you might get 1 mark. If you get it 100% wrong, nearly you get 0. So let's look at this one, because again, why I want to mix it up is this now takes you back. Sure, when did we do this? Was study unit 4. Okay, so probabilities and those kind of things was in study unit 4. So let's look at which one of the following statements is incorrect with regards to experiments, counting rules, and assigning probabilities. Okay, which one is incorrect? So an experiment with 3 steps and 2 outcomes, and 2 possible or outcomes possible for each step, has 9 experimental outcomes. So we are basically looking now at possibilities of questions with permutations, possibilities of questions with permutations. So experiment with 3 steps and 2 outcomes. What would you guys have said is that a combination or a permutation? You can just mention in the chat what would you have said in this one. Permutation, combination. Oh, and I see my calculator does not have this on it. Okay, so let me quickly just want to Google online calculator for this. Just to quickly check. So again, you can see on your calculators there's supposed to be an NCR and NPR for combinations and permutations. Another way of looking at this one is to say experiment with 3 steps and 2 outcomes possible. So experiment with 3 steps. There's 1 step. There's 2 steps. There's a 3rd step. Okay. So one. So let's just make sure that we are now doing this correctly. Did I miss now a step? That's one step. That one step. Okay, wait. I've now done this wrong. I now wanted to do a graph on that, but I should have started from the beginning. So let's just quickly rewrite that again. I'm still waiting for you guys to tell me if you think it is right. So that's one step. That's a second step. $14. Sure. Okay, that's let's one step, two outcomes. So I wanted to say it's something like this. So let's just, how did you get 14? That first one, I think, should actually be 8. Let me quickly just, okay, so I just want to quickly see if I can get also to, okay, so at least, yeah, so that is the formula 2 times the power of 3. So that is how we would have gotten there. This is how it will look. So there's 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So that is how the graph would have looked if we needed to nearly sketch it. So that first one was actually the incorrect one. So not 9, but 8 outcomes. So the other one's number of permutations. So I want to permutation online calculator. Oh, okay. Yeah, so that is, so just be very careful when you do that you don't count all the branches as well, and not just the final answer. Okay, so I'm gonna put this online one also in for you guys. So I'll in the chat so that again you can use it in practicing and those kind of things. So total number in sets. So here they tell us we are working with number of permutations of 4 that can be selected from a group of 7, 4 from a group of okay. So there, what is great is there we have a permutation one. So number of permutations 4 of 7. And then we actually, in this online calculator, we also got the combination one in it as well. So the number of combinations of 4 items that can be selected from a group of 7. Okay, so those two are correct. On your calculators, you will also get this buttons NCR, NPR, even in Excel. And again, remember they said you can use Excel, but it needs to be clean. But there you have a permutation. So let's quickly check if we can get that and if it is the same one. So there's the permutation, 840. And if you did a combination, let's quickly check. Returns the number of combinations. Again, there you will also see the 35. So again, I will share this with you as well so that you can just see the, so you, for this, you didn't need a pre-set up Excel spreadsheet because you are allowed to use the formulas that is built into Excel. So it's not that you're not allowed to do that. So these things is actually quite nice if you need to just use the calculator types of thing within Excel. In an experiment with 5 equally likely outcomes, each experimental outcome has a probability of 0.5. So 1 over 5 will give you that 0.5. Okay, so that is how we would get the 0.5. Sorry, the 0.2. And then the last one, the classical method of assigning probabilities is appropriate when all experimental outcomes are equally likely. Okay, which is also true. So that again is, if you look at one of your definitions, that will just be one of the definitions. So you guys can see now in this one where whenever the student did this, you got 0 because if you probably said permutation or combination, where you see because they said those two are wrong or that one was wrong, it's not that question A is linked to any of. If it was that A or B would have been the wrong one, that is where you then would get 1 mark or a half mark. But you can see with something like this question, there's nearly, except for B and C, there's no link between the other ones to nearly be able to give you a half mark or mark. So it's also not that all questions will be able to give you an extra one or 2 marks, but this might be then in the exam one of those that is only 2 marks or something like that. Okay, so then back to degrees of freedom and looking at the T table. So, and then after that, we will look at something different. So consider a T distribution with degrees of freedom of 27. Which one of the following statements is incorrect? So it's that one again that we have of degrees of freedom 27, and we nearly need to look at, I just want to quickly see what is. Let's take that one away. Okay, and let's make this a bit bigger. Okay, so we are looking at that of 27. So let's even highlight it. Let's see if it actually corrects it for me. Nah, not really. But there we have the 27. So let's just make 100% sure again. So let's the t value associated with a lower tail probability of 0,025. So 0,025. There we have it. So 0,2,0518. 2, so we can see, let's just see 0,02, sorry, 2,052, 2,052. Because it's lower, there is a negative. So it's just like the t distribution is like the z distribution. So on the one side, you have a positive, on the other side, you have a negative. So just like your z, the t distribution is exactly the same. So it has a lower tail. Other ones have an upper tail as well. The t value associated with a lower tail of 0,01, 0,01, so 2,473, 2,473, lower tail, so it's negative. So that is also correct. We're still looking for the incorrect one. 95% of the area under this t distributions should fall between and then 80 and then 90. Okay, so if we look at this, if I say 95% should fall between, so that is 95% should fall between the upper and the lower. But then remember, on this side, there's a 0,025, the same as on this side, there's a 0,025, because everything underneath the curve needs to count up to or the sum of 1. Again, probabilities are equal to 1, so it will add up to 1. So let's see if we look at the degrees of freedom of the 27. We look at 0,025. Where is... Okay, so again, it is that one. So 2,052, 2,052. That one is incorrect. So you can see they referenced the 0.05. Okay, that's also interesting. So let's also look at 80. So if it's 80 in the middle, there will be a 10 and a 10. So we're actually looking at then for the 80 up until that space is 90. So what is left is 10. So we will look at 0, 1. So 1,314. 1,314. The positive and the negative minus 1,314. So that is correct. And then the same for the 90. There's 90 in the middle. So there's a 5, there's a 5. So what we're looking for is going to be at the level of 0, 0.05. 0, 0.05. 1,703. 1,703. 1,703. Positive and negative. Okay, so that is nearly how to read from the t-table if you need to do differences in the t-value, or if you need to look at lower level, they could have asked upper level as well. This question has been in quite a few assignments and in previous exams, so they love to ask something like this, and not sometimes, most of the time, they just fiddle a bit with the degrees of freedom nearly, so that you just need to move up or down from that table. Okay, so let's do this one. Also from a previous assignment. I think this was around assignment 1 of a previous year, where we looked at the difference between, and that is basically where we started off the year. So think back to nearly March, April, difference between population and the sample, and how we actually from there went to do differences between populations and samples for a lot of other study units. So here, this one was a bit of nearly going back to what links with what. So a statistic is an estimate of a population parameter, and we want to know which one is incorrect. A statistic represents a property of population. So I always said, okay, let's look at statistics goes with sample. So here, statistic represent a property of a population is incorrect. It should be of sample. A statistic is a summary measurement calculated for a sample. Correct. A sample standard deviation is a statistic. Correct. A sample mean is a statistic. Correct. Okay, so this was again a bit of a previous study unit 1, but now that you guys have done study unit 7, 8, and 9, this might now be a bit easier as well. And if you now nearly see it in that context, you guys were always now looking at, is it a population standard deviation or is it a sample standard deviation? So in a sense, study unit 1 just made And at that stage, one didn't know where this would have been going and what you would have been nearly using it for at that stage. Okay, so another one with a bit of confidence interval. Okay, so simple random sample of size 19. Sure. Okay, so let me just write down here size 19 from a normal population results in a sample mean 200. Sample standard deviation of 50. So automatically, when we see that sample standard deviation, we know we're going to do a T. Conduct a 95% confidence interval estimate of a population mean and choose the correct answer from a list of options below. Okay, so 200, sorry. Yeah, sample mean 200 plus minus the T, standard deviation 50 divided by square root of 19. Okay, so what is the T? Degrees of freedom, it's 19 minus 1, so we're doing 18. Alpha is 0.05 divided by 2. So let's hope that looks like a 2. So that is 0.025. So 18, 0.025, 2.1009. Wasn't that, just quickly, I let that now sound just like, okay, a bit different, just slightly different. Okay, so 50 divided by the square root of 19 is 11.47 times 2.1009. So plus minus 24.099. Okay, so again, probably going to round it off a bit so that the top one is 224.10. 224.10. That is, then the bottom one will be 275.9. Okay, so again, this one, the important thing was to identify that it is unknown, the standard deviation. So when they tell you it's a sample standard deviation, that means that your population standard deviation is unknown. So yeah, cool. So let's look at the next one. So in this one, why it gives me, that's the issue to make it bigger. Let me just, range. We just see what is. And it is weird that I can't just make it bigger. Okay. I just quickly want to stop sharing and see if there's something in this one. Why that screen doesn't want to. Okay, strange. Let me share again. That is just weird, but it doesn't want me to make that bigger. So let's then just make it bigger on the screen. Okay. Okay, so let's look at this question. Consider the following experiment, and I think if I can remember, something like this was in your assignment as well for this year. Consider the following experiment, the outcomes from the prescribed book. So there's experiment and the outcomes. Suppose that experiment 4 of rolling a dice is conducted 3 times. Determine the total number of experimental outcomes and choose the correct answer from a list of options below. Okay, so you've got 6 outcomes. So what I would have said is very similar to that previous question. 6 outcomes, and you're doing it 3 times. So 6 times 6 times 6 will give you 216. Okay, so your first roll, you've got 6 outcomes. Then you repeat it, you've got 6 outcomes. You repeat it, you've got 6 outcomes. So in total, you then basically have the 216 outcomes because it's 6 times 6 times 6. If you looked at, let's see, you do a toss of a coin, which was heads or tails. So if it was that one, you would have said heads or tails times heads or tails times heads or tails. So that is nearly looking at that same question that we had earlier. Let's just quickly. So the same question of earlier, now just in an example. Where was that? So experiment with 3 steps and 2 outcomes. So that is very similar if we did the heads and tails and said we're going to conduct it 3 times. So experiment with 2 outcomes done 3 times. Okay, so very similar. That first one, if we add that as a question, it would have given us the same answer to that other one. So very important nearly how they can ask you things in a very mathematical way, or they can use a very experimental way, and basically some of it you still get the same answers. Okay, so here is another one. This one I can, strange, I can. Okay, consider the, okay, we don't have a previous question, but we're also saying with a simple random sample of 16. So simple random sample of 16 from a population with a standard deviation of 120. Okay, so I assume that is a population standard deviation. We will see soon. What is the margin of error for a 93% confidence interval estimate for the population mean? Okay, that is an interesting one. So let's just quickly see. So margin of error. So we don't have this component, but we don't need that. So the margin of error, remember, is so that is standard error. And this one is your margin of error. Okay, so that is the biggest difference. So standard error would have been 120 divided by square root of 16. So your standard error would have actually been 50. Okay, so that was the first thing that I wanted to test here. Do you know the difference between standard error and the error, the margin of error? So that's the first thing that I wanted to test here with you guys. So if you say 50, you probably would have gotten or 0 or 1 out of 4, because that only then references a component, but probably 0 because you did not include the multiply by a z or a t. Okay, so probably more likely that it would have been 0. Okay, so then basically, how do we work out what is that value? So let's quickly, so now I actually assume that they, from a population with a standard deviation. Consider the previous question with a simple random sample of 16 from a population with a standard deviation of 120. Let's just quickly check. So there wasn't, so it's not linked to, I'm now just wondering, is that sample standard deviation or population standard deviation? So it might be that the previous question told us a bit more. So if we set this is unknown, we would have gone with a t. T distribution then is Okay, so just remember 93 you will not get in the exam. So don't worry about the 93. But let's just quickly see how you could have, so if it was t, it would have been 15, then it would have been 7% divided by 2, so it would have been 0.035. Okay, and that you will see we don't have that on any of the tables. If it was standard deviation known, we could have gone with a 93. That will then, in here, we would look for a 93. So it would have been around 1,447. Okay, so I would have gone with this to say, I don't know what I would have said. That is a sample standard deviation because we talk about the sample. Then I would have actually used Google. That's why I said don't worry too much about this one for the exam. But let's look at T-table calculator. Okay, so two-tail, I will add this for you guys as well in the chat so that you can play with it. Significant level, so it was 0.07 and degrees of freedom was 15. Okay, so let's quickly. Okay, so the degrees of freedom 1.95. Sure. Okay, so that's also not. So if we set 1.95, 1.95 times 50 is 58. Let me just quickly check. Okay, sorry. That was 0.035, 50. Oh, how many times am I gonna press reset instead of calculate? Okay, it becomes bigger. Okay, so that is quite interesting. So we're not getting it with a t value. So then, ooh. Okay, and where I did that one wrong, so it should have been 0.035. So let's go to where that is 0.035, 0.035, 0.030303035. Okay, so an actual fact is lying between those two. So with a Z, it is 1.815. Let's see, 30 times 1.815. 815. Okay, gives us actually that. Okay, so how do we know from this question that we are actually working with a population standard deviation? Okay, so then we need to read that as, I don't really like this one because population with a standard deviation of, so obviously with my, that we should have read as standard deviation is known. Sure. Okay. Yeah. Again, not English, not my first language, so I did not read it as that. I read it as a simple random sample of 16 from a population with a standard deviation of 120. So I did not connect that it is a population standard deviation. I connected it as a sample with a standard deviation of 120. Okay, so if apparently if you then look at it as a Z, you actually do get 1,815, which will give you the 54,48. So if I used the T, there wasn't an answer. Okay, so this is quite for me, the trick is more with identifying the standard deviation if it is known or unknown, so that you know if you need to use a Z or T. But just quickly for you guys again, so I think that is the important thing is how we would have done it is that in here is 93%. So that means this component and this component together is the 7%. So on this side, it's 3,5%. On this side, it's 3,5%. So if we needed to work out that value of Z, we will go to the easiest one is the negative Z table, where it is 0,035. We will get 1,815. If we wanted to look at the positive side, we needed to look at, what is it, 96.5? Let's see, 96.5 or then 0,965. Then we look in the table 96. Okay, so there 965, 965. So on the positive between those two, it would lie. So it would have been 1,815. Okay, so that is how we would have then looked for it. So just again to show you guys how some of the work we did in chapter 6 and 7, how we would then have used it in this was chapter 8 and 9. But yeah, again, English is definitely not my first language, so that we should have seen as population standard deviation. Okay, so let's look at, I'll just quickly just bring in this another one before we, now this is again not playing. So why is this doing this? Okay, I will sort that out, that we can show those questions as well. So let's just quickly check. Okay, so this was also from one of your previous assignments. I think it was one of the previous assignments. So let's look at it. Let's see what is in here. And let's just quickly see how to look at this one as well. So again, please, if you have any previous assignments from 1 to 5 where you had issues, where you might have taken a picture, don't worry, it's fine. Send it to me, send it onto the group. You can do both. That we work through those questions. If you have any of the mock assignments where there's questions on that we need to work through, please send it on. So this was one student that shared this with me. So please, you can send it to me, or you can send it on the group. I will put it into this presentation, and I will just build on it. So by the time that we're done, you will have a massive pack of examples that you have to prep for the exam. Okay, so consider the Glow toothpaste quality assurance example in the lecture notes. If you were there, the production line for the Glow toothpaste is designed to fill tubes with a mean weight of 180 grams. Periodically, a sample of 50 tubes will be selected in order to check the filling process. Okay, so we've got a mean weight of 180. We've got a sample of 50. So let's quality assurance procedures calls for suppose that the sample of 50 toothpaste provides a sample mean of 183 and a sample standard deviation of 6 grams. So sample standard deviation of 6 grams. Which of the following statements is incorrect? Okay, so we've got a p-value where they say p-value is also between 0.01 and 0.005. P-value is 0.02, so between those two. Okay, so we're going to work it out, but let's first look at 0.0062 is between 0.005 and 0.01. Okay, so that one and that one can't be both correct because we're only looking for one correct answer. So just if you look at those two in combination, so here's the timeline or a number line. So there's 0.005. Then you have your 0.0062, and there you have your 0.01. Okay, so that means both of them is correct. So I would then say both of them is incorrect. Okay, because you can't have both of them correct. So let's look at the others. At the 3% level of significance, we do not reject. At the 1% level of significance, we reject. Okay, so that feels very similar to that nearly. Okay, so let's work out what your Z value is, and then we can work out the P from there. Okay, so let's quickly look at the Z. So we are saying, okay, so that was, sorry, that was the mean. That way around. So 183 minus 180 divided by square root of 50. Okay, so let's quickly check what that answer is, and that will then tell us if we can look at the 1% or the 3%. Okay, so 183 minus 180 is 3. So let's look at 6 divided by square root of 50. And that will be then equal to 2,74. Okay, so 2,74. So let quickly, I want to just rewrite these numbers at the top so that I can make space for myself. Okay, so then when we look at the p-value, just imagine that is a normal distribution, 2,74. Suppose that the sum provides that. Okay, so let's look at what that p-value is at 2,74. Let's go to the 2,74 will give us that space. So let's rather just look at the minus 2,74 to see what is the p-value. So minus 2,74. Okay. 0,0031. 0,00. That is interesting. So let's quickly see. Oh, sorry. Okay. Again. So I went to automatically to Z. It should be T. So let's quickly check. So that is still the same, but population standard deviation is unknown. So we would have gone with a T of, and did they say anything else? So not really. So 2,74, that is correct. That's correct. So we are definitely missing something here. What are we missing? Hmm. How do we get to that? So let me quickly, they don't tell us. So if that is for T, that's fine. Degrees of freedom 29. So they don't tell us. So if we used 29 and the closest to 2,74, is that 0,05. So that times 2 is 0,01. Okay, but is that how they? It would have been interesting. I am going to ask the lecturer for what he's shown in the class as well. So what I would have done is I would have used the 2,74, the T, with the degrees of freedom of 29, and that would have given me nearly the 0,05. So if I multiply that by 2, I would have gotten 0,01. So, but then again, it is close to that one and that one. Is there, let's quickly check. This is not going to help. We need it the other way around. So let's quickly check in Excel. What is the formulas in Excel? I want to quickly see T. T distribution. So what does it? X. Let's quickly check. I don't think this is the right one to use. I just let's say false. So it would have given us what we are looking for. So it is between 0,01 and 0,02. So that is sure. Okay, so it again, standard deviation unknown. So the unknown part makes it that we are working with a T. Then if we're working with a T, we need to find what that t values probabilities of a p value. So let's quickly just quickly check if I have an online calculator. So let's just okay, so P from T. So let's quickly check. 2,74. Degrees of freedom was 29. Okay, so it also gives us the 0,0104. 0,0104. So it's a bit just slightly different, but it does give us the same answer. So it is between 0,01 and 0,02. Yo, okay, so I again gonna copy this in the chat. That is another one that you can reference. So yeah, what I would have done with this one is, like you now seen, I would have looked at that number and I would have checked here 29 with that. So I would have said it's probably 0,05 times 2 because 2 tails, so it's 0,01. Might be a bit more, but sure, this is not a very great question to have had in your assignments if this was one of, I think this was one of the assignment questions. So not really not the easy one. It's different if it was for population standard deviation where it is known, because then it would have been a Z. With a Z, you would have actually gotten that p-value, but then again, that is exactly the same. So quite interesting, this one. But I am just going to ask the lecturer as well what was missing here, because it might have been that in the class session there might have been something that he referred to that could have been used in this. Okay, quite a difficult one. Okay, so let's look at another one like that. So where you got consider the following hypothesis. Um, this was still to do with assignment 4. So hypothesis testing. So in the sample of 100, the sample proportion is 0,83. Calculate the p-value for the test and choose the correct answer from a list of options below. Okay, proportion, we work with a Z. So that is just the important thing. So let's look at the proportion to work out the Z. So that would have been 0,83 minus 0,75. Then obviously important to to just check how we work out the standard deviation or standard errors, sorry, when we work with the proportion. So let me just get that again from my notes. I don't always remember that one. So divided by n, the square root of it. Okay, so that was 0.75 times 0.25, and that divided by n and the square root of it. Okay, so 0.75 times 0.25 is equal to 0.188. Can that be 0.75 times 0.25 divided by 100, the square root of that? Okay, my calculator is now taking this very slow, so let me just do this more step for step. 0.83 minus 0.75 is equal to 0.08. And then 0.75 times 0.25 is equal to 0.188 divided by 100, 0.002. And if I take the square root of that divided by 0.043, so that gives me a Z of 1.85. So if I go again, I will need to go to the Z table, but let's see 1.85. It is looking for my alternative hypothesis is bigger. So I'm going to look for that p-value. So again, I can look at the negative and just, so let's quickly check 1.85 minus 1.85. So let's just quickly clear up this a bit. Okay, minus 1.85. See, yes, 0.0322, 0.0322. Okay, so 0.0322, that would have been the p-value. And again, it's one directional, so it's only the one side. If it was both sides, it would have been 0.0644, which is luckily not there. Okay, so yeah, that is your answer, 0.0322. Okay. Okay, so let's just, I know I want to do this one, but really don't know why it does not allow it to. Okay. Okay, so there was an issue with me when I copied this into Power. Okay, so I will redo some of those. Okay, so let's, and that's probably going to be with all of these. Okay, so let's then just drag it to the middle, and then we go into it a bit bigger so that we can see it bigger, not smaller. Okay. Okay, so let's go. Okay. So hopefully this is a bit better for you guys to see. So here we are busy again with probability. So suppose that two events A and B have the following. So A, B, and the and. Which one of the following statements is incorrect? Okay, so let's first look at, so you have a probability of A and B, which is 0,05. So if you needed it to be mutually exclusive, A and B would have been equal to 0. So let's just look, events A and B are not mutually exclusive, correct, because if they were mutually exclusive, it would have been equal to 0. The other one that I normally test as well is independence. So if probability of A times B is equal to the and, then we know it is independent. So let's just check if it is. So 0,7 times 0,5. Let's just quickly work that out. 0.7 times 0.5, 0,35. Okay, so that is equal to the and. So this means that A and B are independent. Okay, so let's just look. Events A and B are not independent. Okay, so that is the incorrect one. So if they give me the and, I would normally look for mutually exclusive questions first, and then I will look for independent questions next. Okay, so we basically got to see which one is not independent or not correct. Okay, so let's just look at the other one. So A or B. So A or B is probability of A plus probability of B minus probability A and B. So that is 0.7 plus 0.5 minus 0.35. So if we look at that, 0.7 plus 0.5 minus 0.35 is equal to 0,85. So correct. Probability of A given B. So how I always remember this is to say it's the probability of the two, so A and B, divided by the probability of the second one. So probability of A and B, 0.85. Probability of B is 0, sorry. Probability of 0.35 is the top one, divided by probability of B, 0.5. So 0.35 divided by 0.5 is equal to 0.7. So that is correct. And the probability of a complement A is 0.3. So the complement is 1 minus the probability of A, which is 1 minus 0.7, which is equal to 0.3. So you can see the complement is also correct. Okay, so that is, I want to do one more so that, and then we can call it a night. So then on Sunday, we just going to continue. It will be recorded again on Sunday as well. I will share it. And then next Thursday, we just continue. So I will just, and please, anyone listening as well to the recording, please send me your questions. We'll just add more. As you can see, I have already, there's about 39 slides. So we will just add more and more. I have previous exam papers as well, but that was paper-based papers that I will include here. But if there's any other questions that you guys have, please also share. Okay, so let's look at this question. So again, probability. So just for interest's sake, see how this is so in line with your work that you just did on chapter 10 of chi-square. So basically, chi-square is also nearly looking at probabilities of things happening, just a different measurement. So chi-square, you will basically work out a chi-square value, and you will decide if you reject or not reject the hypothesis. Here we're just working on the probabilities, but exactly the same. So we could have, for this observed values, we could have worked out an expected value and things like that. So let's look at what they give us the data. They tell us there's 195. The first thing I'll see out of this is, weirdly enough, here is a 1 that is a 0. So if I need to pick incorrect one, the first thing I can say is heavy and secretaries. So heavy smoking and secretaries is mutually exclusive. So let's look. If event secretaries and smokers are mutually exclusive, okay, it's correct. So I'm looking for the incorrect one. Okay, so because that was 0, it means that the probability of secretaries and heavy is also going to be 0, because 0 divided by anything is going to give you 0. Okay, so I thought that might be a a nice one that we could actually, I thought it would have been the opposite, but unfortunately not. So we still need to look. Okay, so here's things that we need to work out with the and a or. Probability that the rodents is, okay, so I would first go with C and D, the probability that a random chosen staff member is a junior employee. So junior employee is basically all of those added divided by 195. So let's just do that. So all of those added, so it is 18 plus 24 plus 34 plus 13 is 89. 89 divided by 195 is equal to 0.5456. Okay, so unfortunately that is correct. But again, I would, before I go with the ands and the ors, I rather work out the easier ones. The probability that a random chosen staff member is medium smoker. So medium is going this way. So it is 3 plus 8 plus 12 plus 34 plus 7, I think. So let's just take away that. Plus 7. So that would give us 64. So for that one, 64 divided by 195. 0.328. Okay, correct. Okay, so then the next one is the and, which is always the easier one because it is just the value. So the probability that the random chosen staff member is junior and medium smoker. So it's the 34 divided by the 195. So 34 divided by 195, 0.174. So that's also correct. And so that one is the incorrect one, but let's just see why. So the probability that a random chosen staff member is junior and medium smoker. Okay, so we've got junior, we've got medium smoker. So we actually have needed to work out the others in any case. So we've got that, we've got the and. So that will give us the or. So 0.456 plus 0.328 minus 0.174 will give us the or, which is 0.61. They say it's 0.785. That is why option B is the wrong one. Okay, so we would have in any case needed to get to B, we would have needed to work out what is junior employee. We would have needed to work out what is your medium smoker. We would have needed to work out the and to, in the final case, get to that answer. So it didn't, there wasn't really a shortcut in this one, because that is how we needed to go in this question in any case. Okay, guys, so that is it for tonight. Just wanted to see that that we have done. So that we just keep off track where we end off. Just do it this way. Cool. Okay, great. So we did. I just quickly want to run through it again, so that we just quickly see. So if we missed anything, we did that. We did that. Okay. So that will be where we start off on Sunday. We just continue. I will just bring in more examples. So please again, share if you have other examples that you want me to work through, please share it. And I will just add, and we will just continue and build up this pack with more examples that you then have access to when you're writing exams as well, because again, it might be that there are similar questions popping up in your exam. So again, if there's any other questions that you do have that you want me to look at, please send on, and I will put it into the presentation. Okay, great everyone. As always, thank you that you guys are joining, and I will share the presentation and the PowerPoint